Welcome back to using Terraform with Azure Cloud. I'm Matt, and in this next video, we're going to take what we learned in the last couple videos and create a configuration which will spin up some resources in Azure. For this configuration, we're going to keep things simple. First, we'll go through the steps to define the AzureRM provider using the example from the documentation. Once that is set up, we're going to write some Terraform code that will create a resource group. Then we're going to create a storage account to put inside that resource group. Okay, let's get started. We need to create a folder to house our Terraform files. When we run Terraform, it will run against this directory, so make sure to put it somewhere easy to find. On my local C drive, I have a folder called Code, and that's where I'm going to create my new folder. I'm going to call my folder Lab1. Now right-click the new folder and click Open with Code. This will open VSCode where we are met with a warning. This is basically asking if you trust the authors of the files in this folder, because it could contain code that gets executed on your machine. Since I trust this folder, I'm going to check off this box so I don't get this warning anymore. We're going to need to sign into Azure since the AzureRM provider will be using Azure CLI for our configurations. So let's go up to the terminal dropdown and hit New Terminal. This will spin up a new PowerShell terminal inside our lab directory that we can use to run our Terraform commands. But first, we need to authenticate to our Azure subscription. To do this, we will run the AZ login command. This will open a browser window with a sign-in prompt. Sign in to your Azure subscription using your credentials. Once you have authenticated, you can close this tab. Back in the terminal, you can see that we have been successfully logged into our Azure subscription. You can also see that it looks pretty empty in here. So let's go ahead and add a couple of files. A typical Terraform configuration should start with 2 files. main.tf and versions.tf. Splitting up the configuration into multiple files isn't a requirement. Terraform will run against this directory and will combine all TF files into a single configuration. However, dividing things up helps with keeping everything neat and organized. We'll explore this more later on in the series. Let's start with our versions.tf file. The versions file is typically used for defining providers and version requirements. In the previous video, you may remember seeing this on the AzureRM provider overview page. Let's go back and check that out. When we click on Use Provider in the upper right, we're given the code we need in order to get started. Copy that code and paste it into your versions.tf file. This gives us a few blocks of code. For now, we're going to concentrate on the required providers and the provider blocks. Required providers is just what it sounds like. This is where we define which provider or providers we will be using in our configuration. Terraform uses this information to download the necessary provider files that will allow us to start managing resources. Within the required providers block, you can also see that we can set version requirements, so if your configuration requires a certain version, you can specify that here. Now let's look at the provider block on line 10. Some providers allow for additional configurations within this block. We won't be using any here, however it should be noted that the AzureRM provider requires a features block. Without getting too detailed on this, the features block is used to configure some default behavior of certain resources that are being configured. They mention as an example that you can set it up so that when a virtual machine is destroyed, the OS disks are automatically removed, or vice versa. I'll post a link to this page in the description below. And since a features block is required, and the configuration will fail without one, we're just going to pass a blank one in like this. Now that the provider is set up, Save this file, and let's move over to main.tf. This is where the main part of our configuration will live. The first resource we need to create is a resource group. So let's go back to the AzureRM documentation and look up resource group under documentation. Under resources, we can find a good example of how to set up a new resource group that we can repurpose for our configuration. Go ahead and select the example and copy and paste it into main.tf. Now we have a few values we need to update for our configuration. First, let's look at the resource name. This name will be how you reference this resource throughout the rest of your configuration, so make sure it's something useful and understandable. For this example, I'm just going to call it RG1 for Resource Group 1. Now, not to be confused with the resource name, the next thing we're going to change is the name argument. This will be the name of the resource group when it's created. Let's call it RG01. And since I'm not in West Europe, I'm going to change the location to East US 2. That's it. The configuration for our first resource group is done. Let's go ahead and save main.tf. Now it's time to break out the Terraform commands. The first thing we will need to do is to initialize this configuration using the command terraform init. Initializing Terraform tells it to go out to the registry and download the provider files for whatever we have specified under the required providers block. First, make sure our terminal is inside your lab folder, and let's go ahead and run the initialize. Let's take a look at the output. As you can see here, Terraform took our TF files and found the required providers and downloaded the version of the AzureRM provider that we specified above. And if you look under the Explorer pane on the left side of VSCode, you'll also notice that it created a new folder called .terraform and a file called terraform.lock.hcl. You don't need to do anything with these files. Terraform will manage them for you. Just as a note, the .terraform folder is where the AzureRM provider gets downloaded so it can be used when we run our plan next. Now that we're all initialized, the next command to run is terraform plan. The terraform plan command will create an execution plan based on your configuration. This plan will let you preview the changes that Terraform intends to make to your infrastructure. It will read your current state, if one exists, then compare that to the resources in Azure to see if they match. If there are any differences, Terraform will output the proposed changes that would be made if it is applied. The plan command alone will not modify any of your infrastructure. So let's run a plan right now. When the command finishes, we should see an execution plan. In this plan, we can see that a green plus means that a resource will be created, and we can also see the details of the resource group we're creating. Some attributes won't be known until after the resource gets created, so those will be specified with known after apply. And finally, at the bottom, we can see a summary of the execution plan. This plan is telling us that 1 resource will be added, 0 will be changed, and 0 will be destroyed. If you don't see this execution plan, double check to make sure that you saved both your TF files. Now that we've seen the execution plan, the next step is to actually apply the configuration. To do this, we'll be running the command terraform apply. Terraform apply is first going to run a new plan, but it doesn't automatically apply the configuration, unless you specify the auto approve argument, but we won't be getting into that for this lab. Let's go ahead and run the apply. In the terminal, you should be able to see the same execution plan that we just had, but this time Terraform is waiting for a response. The message says, Terraform will perform the actions described above. Only yes will be accepted to approve. Just like it says, and apply will only proceed if we type yes and then hit enter. Anything else, and the command will exit and nothing will happen. Let's type yes and hit enter. After the apply finishes, we can see the output of our resource group getting created. Let's go over to the Azure portal now and check out the new resource group. In the portal, go to Resource Groups, or you can search for the name of your resource group in the search bar on the top, and we can see that RG01 has been created. Now let's add another resource to our configuration so we can see how that changes the plan and apply. Head back to the AzureRM documentation, and in the filter box, put in storage account. Under the storage category, we can find the resource documentation for AzureRM storage account. From the example, let's just grab the AzureRM storage account block. We don't need the resource group from this example because we already have one defined. Back in our main.tf file, let's paste the example underneath the resource group. Once that's done, we just need to update some values. First, I'm going to set the resource name to SA1 for storage account 1. Now for the name argument, keep in mind that a storage account name must be globally unique, so make sure to pick something that hasn't already been used. They also only accept lowercase letters and numbers. I'm going to call mine AC Storage, then add a few random numbers at the end. Next, we'll grab the resource group name from the resource group above. And then for location, we're going to use EastUS2 again. Another thing I'll mention is this example uses GRS, or Globally Redundant Storage, for its replication type. This is a pretty expensive type of storage, so I'm going to recommend for your testing that you use Locally Redundant Storage, or LRS. Now, something else that you probably noticed is that this example had the tags argument specified. Let's go ahead and add that same tag to the resource group. This will show up as a change in our next plan. Alright, let's save main.tf, and let's go ahead and run the Terraform plan again. You should notice some differences in the new execution plan right away. If we scroll up to the beginning, we see the green plus for creating resources, but now we see a yellow tilde which specifies an update in place. Some resource or attribute changes can be done in place, but in some cases, a change will require a resource to be completely recreated. The AzureRM provider will tell you if that is the case. When you look at RG1, we can see that it is the resource that will be updated in place, and that update is going to create a new tag called environment with a value of staging. Then, below that, we can see the attributes for the new storage account that will be created. And finally, we can use the summary at the bottom to see if the execution plan is what we are expecting. 1 create, 1 change, and 0 destroys. Looks pretty good to me. Now let's run Terraform apply. The plan summary looks good to me, so we'll type yes to confirm. When it finishes, we should see the results of the changes from the plan. Let's go back to the Azure portal to verify. When I go back into the resource group, I can see the new tag that we just created, as well as the new storage account. Now let's clean up our resources that we just created. Removing resources with Terraform is just as easy as creating them. However, be very cautious with the following command. Read your execution plans very carefully and avoid using the auto-approve flag unless you are very comfortable with what you're doing. To remove all resources created by a configuration, we're going to run Terraform destroy. Terraform destroy behaves kind of like Terraform apply, except its only action is to delete. When you run Terraform destroy, it will come up with an execution plan for you first, similar to running an apply. And only a response of yes will proceed with the destruction. Let's go ahead and type Terraform destroy. As we look at the execution plan, note the icon which signifies a resource is being destroyed, the red minus sign. You'll notice the minus sign on both of our resources in the execution plan, which means both resources will be destroyed. Let's type yes to confirm. It could take a little while for changes to propagate, so you may have to refresh a few times. But if I do click on the resource group here, you can see, in fact, that the resource has been destroyed. It just takes a little longer for the UI to populate sometimes. Now that we've covered how to create a Terraform configuration for Azure, in the next video, we'll take this configuration a little further by adding a couple more resources and making the code a little more flexible. Thanks for joining, and I'll see you next time.